Okay, so in this video, I'm gonna show you how to compile CompuCell3D on Linux. So right now I'm on Windows, but I will switch to VirtualBox where I have Linux. It's Ubuntu or Kubuntu 13.04. It really doesn't matter which Linux you use. If you use Ubuntu, Debian, or Mint, they all use the same package manager. If you use Red Hat or Fedora, the package manager is slightly different, but if you look at the dependencies that you need to install before you start compiling CompuCell, there are pretty much no differences. So keep in mind that on Fedora and Red Hat, you might need to change the names of the packages. But on Ubuntu, all you have to do is to effectively execute one command, and this will install all the dependencies. So without actually spending much time talking about those issues, let's go to CompuCell3D web page, and we go to source and binary section. Okay, and then we scroll down to the place where it says Developers Corner, building CompuCell3D from source, and we click Linux instructions. Okay. So first things first, there are a few things you need to install on your Linux before you can compile CompuCell. So those dependencies that you need to install are listed in this section. So you need Qt library, you need PyQt with OpenGL modules, you need Swig version 1.3 or higher. Do not install Swig 3.0 though. We have not tested CompuCell3D with that one. You need VTK, you need QWT and PyQWT, you need QScintilla, you need CMake, and you need Python. So if you are on Red Hat or Fedora, you might need to install those dependencies manually, following the names of libraries that we listed here. If you are on Ubuntu or Debian, all you have to do really is to copy this command, which shows up here on this web page. Literally copy it, open terminal, okay, and paste it into terminal. Okay, so edit, paste. Okay, so when you do that, the CompuCell3D, Linux will ask you for a sudo password. I'm going to type my password. I'm not going to tell you what it is. You can guess. Good luck with that. And in my case, I got a bunch of messages which says G++ is already at the newest version, Python is already the newest version, and so on. That means that I have already installed those dependencies. So in my case, no installation takes place. If you have brand new operating system which you just installed on your machine, what's going to happen? Package manager will download the packages you requested, and it will install. And it might ask you a few additional questions. Do you want some other dependencies to be installed? In which case you will say yes. But for me, all the dependencies are installed. So at this point, I'm actually ready to compile CompuCell3D. So what do I need to do next? If I follow the web page, it says I need to get CC3D repository from GitHub. So notice that one of the dependencies that we installed before is Git versioning system. Okay, so all I have to do now is to create new directory where my source code will be. So I'm going to type make dir cc3d src. Okay. Now I'm going to change. I'm going to go to this directory. So cd cc3d src. Okay. Now to clone CompuCell repository into this directory that I have just created, I simply copy the line from the web page, which effectively is a git clone command. So I'm cloning, paste. So I'm going to clone GitHub CompuCell3D repository into cc3d.rc. I'm gonna hit enter, and Git pulls down all the objects. So this operation should be pretty fast. So I'm not gonna pause video. Let's see how this goes. Okay, resolving details, checking out files. The CompuCell repository is, I would say, maybe 60, maybe 80 megabytes. It's not so large, so you can actually, as you can see, downloads very, very fast. Now, we're ready to build CompuCell3D. So first thing we want to do, we want to open CMake. CMake, again, was one of the dependencies that we installed using apt-get install command. This was the first command that we executed on this Linux box. Okay. So here I'm going to applications, and again, depending on the operating system, you might have different environment. You might not have KDE, you might have GNOME or some other window manager. So you know, things may vary a little bit, but overall, the steps should work across all Linux distributions. So I go to development and I open up CMake console. Okay. Now, in CMake console, I have to navigate to the place where I have source code. Okay. So first, let me get rid of some leftovers from the previous compilation. I'm gonna navigate to the place where I have my source code. Well, it's my home directory, cc3d._src, and I pick CompuCell3D. Okay, so this is where my newly cloned Git repository for CompuCell3D resides. I hit OK. Here, in the next line, where to build CompuCell binaries, I specify where the build system, or in this case, this will be make build system, should store all the compilation dependencies needed to compile CompuCell3D. So I'm gonna type home m and cc3d src install, capital letters. Do not make binaries or the binary output directory the same as the source directory, because what's going to happen is that in the binary directory or the output directory for compilation, the compilers output lots of junk. Well, it's not junk, but lots of files, and you don't want to mix those files with the source code. Okay, so make those separate directories, just like I did, and we are ready to hit configure. Okay, now check this. And the question is, build directory does not exist. Should I create it? Yes. Now the question pops. Another dialog pops up, which asks us to specify the build system. That is, do we want to use regular make files, or do we want to use, for example, Eclipse or Kdevelop or Ninja integrated development environment? In this case, I'm going to use plain Unix make files. Okay, so that's what I'm going to choose, and I choose to use default native compilers. And compiler identification starts, and at this is the step where actually CMake is looking for all the dependencies, and wow, that was fast. And everything is fine. So after all the analysis, the CMake was able to identify correctly all the dependencies, and as you can see, if something was wrong, you would get error message, but apparently there is no error message, so things are fine. So now all we have to do is to let me examine if everything is fine. Yeah, everything appears to be working correctly. So the only thing we need to do, we need to specify CMake install prefix for Linux. So install prefix is the location into which the CompuCell will be installed after it's compiled. Do not, I mean, it's up to you, but I would recommend that you first install CompuCell into your local directory. So I'm going to type home m cc3d install, all capital letters, cc3d install, okay? And I hit enter. I hit configure. Every change that you do to CMake needs to be followed by configure step, and at this point we can generate make files that we will use to compile CompuCell3D. Okay? So make files are generated. Alright. So now where are the make files? Well, the make files, as I mentioned before, are in the binary directory. Binary directory is the directory where all the files associated with compilation, including make files, go. This is the binary directory. So in our console, so I'm going to open a new tab in the console. So cd cc3d, and let me, it says, cc3d underscore src underscore install. Why such file or directory? That's very interesting. Let me check what's going on. No, there is this directory. Of course, I must have misspelled something. So, oh, I see what I did wrong. I was actually in cc3d underscore src, but I have to be in the home directory. So cd cc3d src install. Okay. Alright, so here we are. If I type ls, you can see that we have make file. And this make file was generated by CMake. So if you know the workflow for compiling things on Linux, it's pretty easy. You just type make and that's it. The compilation starts. Okay, and it will take some time. Remember, this is VirtualBox, so it's emulated Linux. So I'm gonna pause the video, and we will, after the compilation is done, I will show you what needs to be done in order to run CompuCell on Linux. Okay, so let me start the video now.